Now for something completely different. We're talking about worktops here, but in a very particular application for worktops. Over to Rupert Han, who's going to explain how you can use a worktop to charge your phone.
Thanks very much, Joe. Yeah, so this is a different talk. It's electronic for starts. It's not about design or materials or stone. So my name is Rupert Han, and I'm the business development and product manager at QLab's wireless charging. So we'll be talking about invisible wireless charging for solid surfaces. And as you mentioned, that's a surface like this, and simply placing your device on the surface and charging your phone through this solid surface. In particular, we'll be talking about how IPC Technology, which stands for Intelligent Power Communication, which is our patented technology, is providing that fast charging for modern mobiles through the worktop. So, a little bit of background about QLabs and who we are. We're part of the HANA Microelectronics Group, which was founded in 1978. We're an microelectronics, contract manufacturing business, publicly listed in Thailand. We have around 10,000 employees worldwide with 6 factories and over 1.7 million square feet of manufacturing space. We make a lot of microchips, components, and electronics that we're using right now. We are a dedicated wireless charging unit within the company, looking to solve problems through wireless design. Everything starts off with our design team that's based in South Korea. And initially, we got into this business through wireless charging in hearing aids. So we manufacture a lot of hearing aids, and we had an opportunity to incorporate that wireless charging into hearing aids to make it easier for hearing aid users to, instead of changing their battery, a bit like AirPods, you just put them back in the slot, and that's the sort of way that hearing aids are developing at the moment. So that's something that we still manufacture today. And the team is now working on wireless charging in EVs in particular. So where QLabs is a sort of consumer-aimed portion of the wireless charging, division. So why we ended up with wireless charging in solid surfaces? Well, when we were studying the market in around 2018, 2019, we could see that new, behaviors were emerging in the way that people charge their phones and live every day. We see in the corner here, there's a sort of new segment coming, which is wireless charging in furniture, whether that be in the public space or in your home, or as we're talking about today, through your kitchen countertops. So why we see this segment coming is mainly driven by the fact that since around 2017, you can no longer buy an iPhone without wireless charging. More and more devices are incorporating wireless charging, and at around 2018, the wireless charging market globally was valued at around £5 billion. But by 2027, it's growing around 20% every year, and it'll be around sort of £30 billion. And that's really driven by the fact that most people now have the technology and don't even realize. And people are sort of used to the behavior of putting their phone down, charging up, and expecting to sort of see it more often. So we knew that, as a growing segment, we wanted to be part of this section of the market. And that actually had a bit of a challenge. And that's sort of how our IPC technology is here to solve that, which is sort of what I'll be here to explain. So what are the challenges of invisible wireless charging? Charging through a solid surface this thick, a piece of porcelain. Essentially, it comes down to the fact that phones are sensitive to temperature. So if you've ever been out in the sun and you try to plug your phone in, you probably see that it says, I'm too hot, I don't want to be charged, right? And that's sort of for component safety and battery safety. So phones and charging anything has to sort of be subject to controlling that temperature. So now when you're charging through something like this, of course, you've got a thicker substrate. And as soon as you have something thicker, of course, you'll need more power. And as soon as you have more power in anything, you have more chance of excess heat sort of building up. And wireless charging does create a small amount of heat, but you can't have too much. And the downside is, or the consequence is that, of course, your phone will stop charging due to overheating, similar to the sort of phone in the sun example. So with that sort of challenge in mind, we'll talk about what is intelligent power communication and how does it solve that through, charging through a solid surface. So just very quickly, there's two fundamentals of charging anything. And in this case example, we'll use the example of wireless charging through a solid surface. Here we have a phone that's been set upon a table, and the QLabs charger underneath that's just been mounted to the underside. There's two things to really look at here. There's what we call the power transfer, which is the physical just sending of the current. That's the wattage. That's the two coils and the current passing over it. And there's the more important side of the equation for us, really, which is what we call the communication. So when you're charging anything, that device has to be able to say things like speed up, slow down, stop, start, I don't want to be charged now. And when you're charging anything, it's that balance between power and communication, and that's how things get from sort of naught to full without blowing up, that kind of thing. And especially when you have a wireless charging situation and without the wire, all that has to be communicated wirelessly. So with that sort of background in mind, we'll just sort of look at what's in the market at sort of the moment. You probably recognize these types of cheap pads. You just stick your phone on top, and you can buy these for, they give these away for free, So that's what we call sort of a surface level charger. And in this case, it's been, a hole's been drilled into the top, and this type of thing just sits in the countertop. It has a power, communication, and transfer distance of around 5 millimeters, and that's to keep the device, very low powered, very cheap, very efficient, and less risk of a heat problem or an electrical issue. If you now want to hide this product and set it underneath the surface, you've still got the power, communication, and transfer of around 5 millimeters. So you've got to now install this at around 2 millimeters to keep within those parameters. And that's a challenge in itself. So when we were looking at the solid surface market, especially when it comes to kitchens, we know that consumers definitely don't want a hole in their countertop with something like this sticking out. And for fabricators especially, and kitchen shops, I'm sure you're all wincing at the idea of routing something to 2 millimeters, especially when it's substantially more valuable than the thing that you're routing it for, right? So what really we needed to develop was long distance charging, or as we sort of call it, invisible charging. And that's anything really that's going over sort of that 6 millimeter range into a thicker substrate, something that can be attached directly underneath and charged through the substrate, right? So what do we need to do that? Of course, you need more power. You can increase the power and just to try and penetrate that substrate. But what we saw a lot of people doing is they're just taking these things and they're just putting it underneath the countertop like that and increasing the power. But what they still haven't solved is the fact that the communication distance is now out of range with that particular phone. So you might sort of think, well, what's the issue with why can't I just increase the power? I mean, why does it matter? Well, this is what happens if you were to take this and ramp up the power like many others have done. You have this situation where the phone is receiving, a lot of wattage, and eventually it's just getting very warm. And that lack of communication means the phone can't say, stop, not now, or slow down, or I'm full, I don't want to be charged. And ultimately, that leads to sort of the overheating and battery damage, and of course, that sort of too hot, I can't charge situation. And so this is why we talk about communication, and we always talk, in any relationship, communication makes the whole thing work, apparently. So it's sort of I'd say that it's the wireless charging equivalent of this, right? You don't want to be in this situation when you're charging anything. So we're going to come back now to, what is intelligent power communication with that in mind. It's essentially the world's first long-distance communication system for Qi wireless charging. So what that means in plain English is that we are able to extend that range of communication through a solid surface. So as we see here, our QLabs charger is extending that range from 6 to 12 millimeters and beyond, so that the phone can be safely set on top, and then it can charge, and if it doesn't want to be, it can stop. If it's fully charged, it will also stop, which is all the behaviors that we take for granted when we plug something in with the wire, but that just still has to be communicated wirelessly, Whereas other units we've seen on the market, they are just these types of products with significantly more power. And that's sort of the main difference there. On now to our charger itself. This is our UTS-1 wireless charger. It's universally compatible with all phones on the market between 8 to 12 millimeters, which means that you can attach it to the majority of devices, of surfaces, sorry, but thicker ones we do advise to be routed in to ensure that compatibility and efficiency. It works with all material, non-metallic materials, I should say. In this case, of course, all stones, as we're talking about, stone conference here. We're doing the Apple and Samsung fast charge protocols. So that, again, that's communicated through that communication system that we're talking about. And importantly for the industry here, we're the only solution that's been approved by the stone countertop brands, and we're trying to really push into the sort of the surface industry to validate our technology, just so to make it more accessible for, so that we're not talking about electronics all day. So what does this device charge? Well, it's all, as I mentioned earlier, it's all iPhone since 2017, most of the Galaxy S range, and now we have products like AirPods, the AirPods Pro that can also charge, and we've also now got, the Sonos Roam Bluetooth speaker, and the Kindle Signature even has wireless charging. So that's all part of that huge growing market of things that people now are just going to start putting on the service and saying, does that work? And we're hoping that more and more things kind of have that. What doesn't have wireless charging at the moment is iPads and Apple Watches and laptops, as they either have a different technology or they require, a lot more power to charge. So how does our charger perform? We do a lot of testing through 12 millimeter porcelain, and we can see that for an iPhone 12 with the MagSafe case, which is the sort of magnet case, it takes around 3.5 hours for a full charge, but maybe 0 to 80 is around 240. So it's not the fastest charging in the world, but it's sort of, especially in the kitchen area, when you're doing a washing up, or you just want them to be charging in the middle of the island, and it's just a great top-up system to keep, so you're not always just running low, or you're getting charged when you're not thinking about charging your phone, which is the main sort of benefit to wireless charging, as well as the aesthetic side of the charger. At the Coverland booth, we have a unit set up if you want to go and fiddle around with it there. But this is to really show an installation within a kitchen island, which I can skip over. So we're just going to now talk about, who's using our chargers. It's not just kitchen countertops. We're also in retail. We're in stadiums in America. We've gone into Walt Disney post-production studios, Gymshark's shop in Regent Street. And we were also named the best invisible wireless charger by Wired magazine 3 years running now, which I'm very proud of. So let's just quickly look at the installation process. It's fairly straightforward. The charger that you see there needs to be mounted directly to the surface. So of course, if you have a carcass in the wardrobe, in the cabinet, sorry, they should be cut. They should be cut to allow that access. You need a power outlet, of course, something nearby. Our unit has a switch for the distance setting, which we would advise based on the thickness what you should set it to. You may be able to see that the unit has tape on it. You would just peel that, stick it straight on, or if you're doing through wood, you would just screw it in with the screws provided for us by us. Sorry. Now, of course, then you need to sort of plug it in, and our unit comes with a range of stickers that you can use on the counter to align it to the coil in the charger, and of course, then you're just placing the device on and charging in your kitchen. So we're just going to run through a couple of examples here. Like I mentioned, we're trying to aim for that 8 to 12 millimeter thickness, just to ensure that it works efficiently. It's future-proofed against these changes that are coming in the phone, with the camera getting bigger and bigger every year, and also to make sure that it charges efficiently. So in this example on the left, we have a 2 centimeter silestone quartz that's being routed down. But on the right here, we have a 12 millimeter porcelain that's just been mounted directly on. So this is the sort of installation types that we see mainly. Uniquely with our product, you may have seen that there were 2 sockets, so you can connect 2 together using 1 adapter. So this is really popular for kitchen islands and breakfast bars, or sort of office installations, to save on plug outlets. So just try and build upon the aesthetic of why install this type of product. We're just going to show an example recently. This is a show home in Canada. that is just been sort of kitted out with our units, which of course are hidden. You can see up in here in the bar area, this is a sort of the entertaining bar area, and that's a 12mm decked-in piece that's had the unit directly mounted in here. And then on the right, we have a 3cm Cambria top, and that's been routed in. And again, that unit's just been installed there. So this is a sort of aesthetic that we think wireless brings to new kitchens, and it looks very slick and very sort of calming, let's say. And it's sort of a motto that I'm trying to push with our company of, basically don't ruin your new kitchens with all your old junk, your old adapters, your old wires. It's one of the main reasons why people get a new kitchen, is to have this sort of new start, fresh, fresh heart to your home, and get rid of some of those old wires and go wireless is my perspective. So just a couple of FAQs on the products. We have a MSRP in the UK of around 120 plus VAT, and that's based off of a US price of $150. We distribute directly here in the UK and offer sort of a standard 1-year electrical warranty. And just the sort of last page, I'll work with the industry here. So our main difference, we think, is that, especially for the kitchen industry, is that we're the only solution that's really pushing to be validated by the Surface brands. So that is to give the kitchen shops confidence to say that this product has been tested and approved, and gives the consumer confidence to know that these two things are something that can be married together and is safe. So we're the only tested and approved solution by Costantino, and now we're approved by Inalco, and just very recently Coverlam, who have a small unit set up here, and Laminam, and we have a verbal approval from Cambria. So we're making technical documents. We have a technical document from Costantino for fabricators and retail stores that tells you everything from what distance to route it into if you have to, and what size to make, and where not to put it close to the edges, heat sources. So we're trying to make electronics as accessible as possible to the surface industry. So that's all from me at the moment. I'll open up the floor to questions if anybody has any.
I was just wondering if there's plans to increase the
thickness.
Yeah, exactly, for 20 mil or 30 mil, so routering doesn't need to be done.
Yeah, that's a great question. So when we initially developed this product, we were actually charging at 1 inch, and the big change that happened was these magnets getting introduced. So the limitation really is the phones and their tolerance to temperature. So as I mentioned earlier, when the thicknesses get more, you have this additional power. So we don't actually see there being much that's going to help us charge at 3 centimeters, for example. But the other point is that even if there was, the amount of power to charge a phone and in a time that you want it to be charged in means that at the thinner distance you're getting a much better efficiency, so it actually charges more naturally. We wouldn't be able to have those sort of 1 or 2% per minute speeds at 3 centimeters. So whilst it would be the dream to just plug it on, put it underneath the 3 centimeter top, it won't be a performance that you would want. And we have an issue that the coils in the phone are not the biggest coils in the world. So as they get further away, trying to hit that coil and also jump through the hoop of this magnet gets more technically challenging. So in a way, that thinner distance gets a better performance and a lower temperature for the surfaces, and keeps the countertop brands happier about excess heat and things like that. So whilst I wish there was a fix, and there are a lot of companies that just say, yeah, 3 centimeters, you can stick it on, and they can sort of make it light up, but then to make it go from 0 to 100 is a sort of a different ball game, which has to be monitored by our communication system, which does actually go up to 25 millimeters, but again we're sort of limited by the physics of trying to charge something that's further away. Yeah, similar to sort of any kind of, like, pylons have to be taller to transmit signals further, and there's a sort of consequence to taller pylons, So does that make sense? Yeah.
I've got one. You said you can't any non-metallic surface. What about if you're using a metallic glaze on a porcelain worktop? Does it still work?
It's a good question. I think it depends on the metallic content or just how metallic it is. So our charger has something called foreign object detection, and that will just detect if there's anything in between a phone and the charger that shouldn't be there, i.e. a piece of metal. So that means if you put a set of keys on the charger, it will detect, oh, that's a piece of metal. Is it a phone? No, it's not, and turn off. So I think we'd have to test that. But I couldn't say. So occasionally we have seen stones with some metallic content, but it's not enough to cause an issue. And that also goes with things like credit cards also have small electronic layers. So we don't recommend cases with the card readers on the back as well. We suggest to take that off. But you'll have to send me something, Joe, to do some testing.
Have you found any issues with performance for different types of stone with different densities? So such as marble or granite or quartzite? Do you have different?
That's a good question. Not really. I think density can create milliseconds of delay when you connect the phone. So one thing we say is when you put the phone on the surface, it can take up to 2 seconds to connect. And we do sometimes think that the density does have a factor that plays into that. But we think stone is quite good as it's very, very good heat dissipator. So and it also gets naturally, quite cold, especially, in the evenings when you don't have your heating on. So placing your phone on a cold surface is actually good for the charging and keeping the phone at a temperate level compared to something like wood, which absorbs heat. So not a noticeable difference, but possibly a small difference in connectivity time.
How do you know where the charger is? I mean, I can see in your own kitchen
Yeah.
island you're going to know, but if you're doing it in a football stadium, how do people delineate where these chargers are?
So we have these stickers that you put on. So the charger itself has a coil, a little sort of ring on one side. So you're trying to aim that label to the charging area. We have an audio calibration system where the unit will make a small beep, and as you move the phone closer to the charging area, which is here, it will beep faster. So that's a sort of consumer way that you can connect it. But for bigger installations, we have in our technical drawings. Hold on. This is the inside of the unit. So we have technical drawings that show you where the XY center of this coil is, and if you're sort of marking out a drinks rail. So we've got a project in a baseball stadium in Washington where they have a long drinks rail in all the suites where people can drink. So we'll just be using the XY coordinates of where that is in every one to make a small marker where they would put a logo or something there, and that's how you would on a mass scale find the center spot, which is what we're trying to do in each install.
Sorry, just one more question.
Yeah.
Regarding the adhesive and how you stick it to the stone itself, is it just those 4 strips of self-adhesive tape that are used?
Yeah, it's just this VHB 3M VHB
And have
tape.
you ever had any issues of those becoming of any of the units dropping out of place? And if so,
Occasionally, yeah, we have had, especially when on building sites can get a little bit dusty, and somebody will peel it off, and then the dust will get on and not stick. So that we do sort of suggest that they should be cleaned and the surface should be cleaned before that is stuck on. But once it is stuck on, I mean, I think they tape planes together with this sometimes. But it is very strong. But if people, it is the type of adhesive that if it gets too much air to it and dries out, it will. So we do get people either siliconing them in, which is fine. As long as it doesn't just cover that center spot there, you can tape the edge and stick it in. So that's typically how they go in. And some things have some of those porcelains have like an under mesh side, and they're also quite adhesive friendly to stick on. Yeah.
Okay, thanks, Rupert. That was really good.
Okay. Thank you.